Oh, hey there, guys. I was just looking at some Hearthstone cards. Hold on a minute. So let's go ahead and get back and talk about our lesson for today, which is called polymorphism. So polymorphism is going to be pretty weird, and this just shows you kind of a cool feature of Java. So before we even do anything and talk about what this is, let me just show you some code. So I'm going to do some weird stuff, and then we'll talk throughout the lesson about what's going to happen. So I'm going to declare an object variable. So I'll just call it object O. But instead of setting it up as a new object, I'm going to set it up as a new integer. Well, that's weird. Usually an object is a new object, an integer is a new integer, but we'll do something like that. Okay, and then in my inheritance class here, I have a car that's extended by sedan and coupe. Maybe I'll just change O to be a new sedan. And I think my inputs there, I believe I have to give it the year and then the string for the brand. So we'll go with my first car, a 1980 Mercedes. The thing was a true legend. We could talk about that in class if you want. And then you know what? I'm tired of that car. Now maybe I'll set it. I'll set up a string. Word equals a new string. Cash, which I'm a teacher, so I don't have much of it. And then I'll just set that object to be that word variable. And then maybe now, after that, what I'll do is I'll take that object and I will cast it as a string. And then I'll call the .length method on it. Okay, and this might seem like I've done some weirdest stuff, and perhaps the weirdest part is that when I hit compile, there are no errors and everything works. So the question that you probably have is, what is going on? And that's what we're going to answer today and what polymorphism is about. So polymorphism, poly means many, morph means change, of course. So polymorphism is basically what happens if you have a variable reference that can refer to different types of objects. And typically these are going to deal with inheritance and the object types are going to be related. So let me just comment this out and then let's kind of talk more about what's going on in this crazy little bit of code here. Okay, so the first thing I wanted to discuss is that if you have the reference to a superclass is flexible. So like obviously I can set up, a car C equals a new car. So I'll set up my current car, a 2000 Volvo. But I could also set another car, let's call it car D, to be a new sedan. So say my 1980 Mercedes Classic. Okay, so this is interesting. And what that means is this works because a sedan is a car by inheritance, right? Sedan extends car. Coupe extends car, right? When I look at these, sedan extends car. So thinking about this, a sedan is a car. So I'm setting a car variable equal to a type of object that actually is a car. Okay, now the other way does not work, right? The other way doesn't work. So I cannot set up like a sedan, not going to work, equals a new car. We'll use my wife's car. I think it's a 2009. I honestly don't remember. A 2009 Hyundai. Okay, but now when you hit compile, you see it gives you this error. And this error says a car cannot be converted to a sedan. And the reason this doesn't compile is because a car might not be a sedan. So I can't necessarily do that. So that's why something doesn't compile. Okay, so now that we've done that, let's try and do this. So we've set up this car and the sedan. So now that I've done that, I want to call car methods on C and D. So what are the methods inside car? Well, if we look at that, there's a toString and there's like a get year and a get brand and nothing else. Okay. So let's take a look at this get doors, for example. This is probably something to be abstract, but by default, I set up a doors variable. So a car by default has 0 doors. When you look at a sedan sets that up to be 4, and then a coupe has 2 doors. I just made it public because whatever. But so that's what's going on there. If I want to call this, for example, let's try and call this. So I'm going to call system.out.println. I'm going to call c.getDoors. Oops. Okay, and then I'm going to do the same thing again, but I'm going to do it on D. So I'll call d.getDoors. Now, here's something that's kind of interesting, right? When I call this, what we're going to see is that it printed out 0 for the first one, but it printed out 4 for the second one, which is something you might think but might not think. So this prints out 0, and that's what we have. That's the car version. But this prints out 4. which is the sedan version. And you might be confused by that because, oh, they're both car variables. They're both car variables. But the issue with that is when you run your code, Java says, hey, what type of object is D? D is a sedan object. So what does the getDoors method do inside the sedan class? So this is like, here is the key from today, and I can't stress enough, key idea from today. When you compile your code, Java checks the declared variable type. So when you're compiling this, when you say car D equals new sedan, the declared type is a car. D is declared as a car object. So what that means is that because it checks the declared type, I cannot directly call a sedan object on D because it is declared actually as a car object. So if I try and find a sedan only method, so for example, I have one in here called gotSpace. So there's a gotSpace method there, but there's no oh, I do have a gotSpace method, shucks. So let's change that. Rear legroom. So this is a method that only happens in the sedan class, not in the car class. But if I try and do this, so if I try and print out like D dot rear leg room, you're going to see this doesn't compile. And the reason it doesn't compile is because Java looks at this and says, hey, D is declared as a car. And you're like, bro, but it's actually a sedan. But that's different. When you compile your class, it just checks what type it's declared as. So that's why this doesn't work. But these work because it's like, oh, C is a car, this method's in car. D is a car, this method's in car. So when you compile your code, Java checks the declared type. But when you run the code, Java checks the actual type of the object to decide which version of the method to use. And obviously, just like before, it's going to use the most recent version. So when we're running this, it says, okay, when I run this, D is a sedan. So I'm going to use the getDoors method from sedan instead of it as car. So that's a difference. This doesn't compile because when you compile, it checks to see what type of variable it is. But when you actually run your code, it says, oh, D is actually a sedan, so I want to use that version there. Okay. So that's kind of the main idea there. Okay, what did I want to talk about next? Now, what if you want to get around this? So to get around this method, what if you want to call a sedan-only object on a variable that is declared as a car? So what if I want to call rear legroom? So let's go set up another car. So let's set up, car E equals a new car. We'll do like my mom's car. I don't know what it is, like a 2010. It's pretty old. Oops. 2010 Lexus, I think. Okay. Now, what you're going to do is you're going to cast this as a car, or cast this as a sedan. Oh, I also screwed that up. I wanted to make this a sedan. So I'm going to cast this as a sedan when I want to call a sedan-only method. So one thing that I want to warn you about, and this should be weird, right? Because the only casting we've really done all year has been in terms of ints and in terms of doubles. But now you can actually cast it as anything which extends that class. So if I want to cast E as a sedan, I need to cast E itself in parentheses as a sedan before I call the method. So what I need to do is say, okay, in parentheses, I'm going to open another set of parentheses. I'm going to write sedan, just like I cast as enter double E, and then dot rear leg room. Okay, so we'll see that compiles. So I'm casting E as a sedan, and then when I run the code, it'll actually give me what I expected, which was the answer there, which was 3. So that's in a sense what's going on here. So you have to be careful. You have to make sure you cast in parentheses, because if you forget the parentheses, what's going to happen here is it calls the method first, right? It does order of operations. It calls this and then thinks you're trying to cast that int. Well, actually, it won't even find the method, but it tries to call the method before the cast. So you need to make sure that you put a parentheses around the cast. Remember, it's never bad to put too many parentheses. Okay, so that's how you can go ahead and call some of these methods. All right, now, what I wanted to remind you of is that what everything works is I can only do this with things that extend car. So I can't, for instance, do, car f equals a new string. Like, this isn't going to work because string doesn't extend car, right? And that's the error message you're going to get. A string cannot be converted to a car. But as long as I extend it, I can be fine. So anything that extends the declared type is fair game. So that's why I could set up, some object O, and I could set it up to be a string. Oops. And then I could change O to be, I don't know, like a new array of ints. And then I could set O to be a new sedan, which is, I don't know, like a 2000 Toyota. Okay, like these all work because string, int array, and sedan all extend object. Now, here's an error that you're going to see. What if you try to do a cast that won't work? So, like obviously the sedan right now extends object, so I could cast O as a sedan. But what if I now tried to cast O, say, as a string? Or we could even do something different with another random type on, like, well, we won't do arrayless. We'll just try and cast a string to save some time. But what if you try and cast O as a string and then call .length? Now, you might be surprised to discover this actually compiles. So this compiles because when Java checks, it sees that O could still be a string. But when I run the code, we're going to kind of run into some issues here. It's going to give me a weird error. It gives me this class cast exception. It gives me all this crap down here. But that's the error. And it basically just says a sedan cannot be cast to a string. And then some unnamed modules that I don't understand at all. But the general idea here is it won't run. Because when it runs, again, Java checks the actual type and sees O is a string, or sorry, is a sedan, and then it cannot cast it as a string. So that's what's going on there, and that's what's happening there. Okay, the only other thing I think I wanted to share with you guys today, hopefully this is interesting. We got casting, we got polymorphism, things saving as different things. This even works with abstract objects. So for example, let's say you have, like, in my class, I have this machine right here. So this machine is just an abstract object. I can still set a machine M to equal a new car. 2001 Honda. Like, this is something that still works very well. And even though machine is abstract, I can still cast as a car because a car is a machine. Okay, so the other thing I wanted to mention was just what happens if you have like an array of machines. So I just copy pasted one in here. So we have an array of machines that has 2 sedans, a coupe, and a car. So this is something you're going to have to do sometimes in your labs this week, is maybe you want to loop through this array of machine objects. And then you want to do something specific. So with sedans, I don't know, I want to call, or I want to print their legroom. And then with coupes, I print their 0 to 60 time or something. Okay, so what the general setup for this is going to do, I'll do a for each loop, but if you want to do a traditional for loop. So you have a list. List is an array of machine objects. So, and that's again going to be anything that extends machine on any level. So that could be car, it could be coupe, it could be sedan. So what I'm going to write this out on is I'm going to say for each machine M inside the list. And you could use a traditional for loop here too, it'll work just fine. But what you're going to do is say, okay, I already have that, ma. So for each ma in here, okay, if I want to check, so first, see if it is a sedan. And that's going to be instance of, right? So if ma instance of a sedan, then in that case, I want to, I don't know, print out the legroom. So we have that method rear legroom. So what I'm going to do here is just say, okay, so in that case, I'm going to print out ma.rear legroom. This might be your first thought. And what you're going to find out very quickly is that this doesn't even compile. The reason being, again, it can't find the rear legroom. Because Java still looks at this, and by itself here, it still sees that ma, or I guess if you do a traditional one like list sub I in a regular for loop, is a machine object. So you call instance of to ensure that it's a sedan, but you still need to cast. So if you want to cast Ma as a sedan, you still need to say, okay, I'm going to cast as a sedan. Okay, all in parentheses. So I cast Ma as a sedan, and then I call rear legroom. So that's how you would go ahead and run this. So when you're looping through an array of objects like this, especially when you're calling instance of to make sure it's a certain type and call a method on that type, this is what you'll have to do. Okay, so that's polymorphism. Remember the key from idea. The key idea from today, when you compile your code, Java checks the declared type, which is right here, the type of variable it is. And then when you run your code, it checks the actual type of object it is, which is the same. Okay, thanks for watching, guys. I know this is a weird topic. Make sure you bring me some questions to class. I'll see you soon.